So in this video we're going to find the inverse of a quadratic function by first completing the square, then solving for the input variable, and then restricting the domain so that the quadratic function we have is invertible. So we're starting with we're asked to complete the square and restrict the domain so that the positive square root is the inverse of f of x. So here's my quadratic function, and to make my life a little bit easier, I'm going to go ahead and make the replacement y equal f of x, just for now. And then I'm going to rewrite it, so y equals negative 2x squared plus 8x minus 3. And then what I want to remember is that to complete the square, the leading coefficient on the x squared term has to be a 1. And we complete the square on the x terms, the x squared and the x terms. So what I'm going to do to get a leading coefficient of 1 on x squared is I'm going to factor the negative 2 off of the x squared and the 8x. So I'm going to get x squared minus 4x. And I'm going to leave some space because I'm going to need to use this. And then I'm going to put my minus 3 out here. So I didn't include the minus 3 when I did the factorization. I only factored the leading coefficient off of the x squared term to get a coefficient of 1, and I factored it off of the x term because these are the two terms involved in the completing the square process. I used distribution to double check my work, so negative 2 times x squared is negative 2x squared, so that checks, and negative 2 times negative 4x is positive 8x, so that checks. So then I still have my y sitting here, and then what I want to remember is that to complete the square we take the coefficient of the linear term, which is a negative 4. We have it just like we did at the start of the semester, then we square it. So negative 4 divided by 2 is negative 2, so the thing that gets squared is a 2, and that's going to give us a plus 4, sorry, an equals 4. And then we're going to take that 4 and add it inside the parentheses to the x term. So I'm going to go plus 4 to complete the square on the stuff inside the parentheses. And then what I need to do is figure out how much I've added or subtracted to the right hand side of the equation. So I haven't added a 4, and the reason I haven't added a 4 is because there's a multiplier of negative 2 out in front of the parentheses that needs or wants to be distributed into the parentheses. So I've really done negative 2 times positive 4 is negative 8. I have really subtracted 8 from the right hand side of the quadratic function. And so what I need to do is get this to zero out so that I've effectively added nothing to the right hand side. So negative 8 plus 8 would give me 0. So if I come out here and I add 8 to the right hand side, so here I've done negative 2 times 4 is negative 8, plus 8 is 0. I've essentially done nothing to the right hand side other than make it look different, because the net result of negative 2 times 4 plus 8 is just a 0. So that's the key, is to take into consideration the coefficient on the parentheses. And then once you've done that, you want to recognize that you have completed the square. And then when you do your x and then something squared, you have to put in here, what did you square? You squared a negative 2, so it's going to be a minus 2. And negative 3 plus 8 is the plus 5. So I've put the function into vertex form. And so from vertex form, I see that the vertex hk is going to be 2, 5. And the negative on the 2 here tells me that I have a parabola opening downwards with the vertex at input 2, output 5. So what we'll do is, to make our quadratic function invertible, because currently it isn't, it doesn't pass the horizontal line test, so I know its reflection in the line y equal x will not pass the vertical line test. What we'll do is restrict the domain. We'll restrict the domain starting from 2, and we'll say, hey, only look at the stuff going this way. In other words, throw away the left side of the quadratic function, and that will allow us to use the positive square root. If we needed to use the negative square root, we would throw away the right hand side and keep that left hand side. So we're going to restrict the domain now. We're going to say, hey, take, let's even be more careful, for f of x, let the input variable x be an element of the interval starting at 2 and going to infinity. So we're only looking at the part of the function that's to the right of that line of symmetry. So if we do that, then we can solve this for x. Because it's in vertex form, we'll be able to manipulate it into a form to which we can apply the square root property. So I'm going to take my y equals -2 times x minus 2 squared plus 5. And to solve for x, we want to isolate the x minus 2 quantity squared. So first subtract 5 from both sides, so we get y minus 5 equals -2 times x minus 2 quantity squared. Multiply both sides by -1/2, or divide both sides by -2. So multiply both sides by -1/2, so we get -1/2 of y minus 5 equals x minus 2 quantity squared. If we want to, we can distribute the negation into the parentheses, which would reverse the order of the subtraction and give us a half of that. And if I just walk my work up here, we then take the square root of both sides. So we get the square root of 1/2 times 5 minus y equals, when we take the square root of the right hand side, it will cancel the squaring and leave us with the x minus 2. And then usually we get plus or minus right here. But because we've restricted the domain so that we're only using this half of f of x, this is f of x restricted on the interval from 2 to infinity. When we do that, it allows us not to have to put the plus or minus. So we add the 2 to both sides and we get the square root of 1/2 times 5 minus y, and then the plus 2. And here's our inverse function. And if we want to put it in function notation, I can just say f inverse as a function of the original output variable, which is now the input variable, is equal to the square root of 1/2 times 5 minus y. If we want to use function notation, plus 2. Hopefully my face didn't cover that up down there.